Okay, today's day 5, implicit differentiation, and we're going to look at how to take derivatives with respect to the letter x, but when we're using different variables. So far we've been working on functions that say y equals f of x, and this is an explicit equation, and we've been using all these different rules to take power, product, blah, blah, blah. So when we have y equals 3x to the fourth, what we've been doing is taking the y prime, or the dx, over whatever thing we want to take. So this means the change in whatever is inside the parentheses with respect to x, or with respect to the change in x. So we've been taking a dy dx, or a derivative of whatever the y equation is with respect to x, and so the d dx of 3x to the fourth, and we know it's 12x to the third, but there really was an extra dx over dx, and we usually do not write this. Because it doesn't really do us any purpose to write dx over dx, because dx over dx is just 1, and we know we get 12x to the third. So we do d dx of 3x to the fourth. We're trying to find the change in this function 3x to the fourth with respect to x, and we got 12x to the third. And we've been doing this for a long time, and we understand how we get that. But how do we handle it when we have different things we're trying to do? Okay, and we know, like I said, all these rules. When we're finding dy over dx, or the y prime, what happens if we want to do the d dx, or the derivative of 3y to the fourth? So this is a different variable than what's in the denominator. And what happens, we get the same thing as before, except now we have 12y cubed, and then we have this little multiplied by this little extra dy over dx. Or sometimes I use shorthand, and I do 12y to the third, and then I write this little thing at the extra. You know, it's called y prime, but y prime is the same thing as dy over dx. So I know my handwriting, so I tend to use the y prime notation, because I would never write y to the first. Y with a little dash on it is not y to the first, it is y prime. It stands for the dy over dx. They mean exactly the same thing. So how do we handle some examples? So when I take this derivative, it's going to be 20y to the third times the dy over dx. And this would be cosine of y times the dy over dx. Notice every single time that I take a derivative with a y variable in the problem, I multiply by this extra dy over dx. This would be 2e to the y times dy over dx. And this would be, this is a chain, so it would be cosine, well, the outside function is cosine of u, and the derivative is negative sine of u. And then I have y cubed, and this derivative is 3y squared times dy over dx. And if I multiply my box, I get negative 3y squared sine of u times dy over dx, or altogether I get negative 3y squared sine of the u, and the u is y cubed, but don't forget to multiply it again by the dy over dx. So these were all my results. circle them so they stand out, especially this last one. But I could have written them all in that shorthand notation and called this 20y cubed times y prime, cosine y times y prime, 2e to the y times y prime, or negative 3y squared sine of y cubed times y prime. These are all the same. It's just that I'm using the shorthand notation. I'm going to do, when I do some of these problems later, I'm going to use both notation. So what we've been working on throughout the last 2 units have been with some function y equals f of x. And that is an explicit function because y is a function of x. Okay, this unit, this topic, we're going to work on things a little bit differently. We're going to work on things like this. X squared plus y squared is equal to 4. This is not a function. It is an equation, but it is not a function because it says x and y is mixed together on the same side. This is an implicit function, and actually it turns out it's a circle, so it's not really a function if it's a circle. Now if I wanted to, I could solve this. If I wanted to solve this for y, I would get this equation right here. Choose. I would get this equation right here. And notice there's a plus minus sign in front of it because technically this is the upper half of the circle and this is the bottom half of the circle. And that's the only way I could represent something, a circle. I have to write 2 half functions, the upper half and the lower half. And I could take the derivative. I could use chain rule to take this derivative, but that's going to be a lot of work. We have a quicker way to take the derivative of this circle function without having to do the multi-layer chain rule and working on that. So this is how we do. I'm taking the derivative of the whole function with respect to x, the ddx of it. Okay? So this is what I did here. I took its derivative and I kind of split it up into its parts. I'm taking the derivative of the x squared, the derivative of the y squared, and the derivative of the 4. Well, we've talked about this. The derivative of x squared is just 2x. The derivative of y squared is the 2y with this extra dy dx, or this y prime, and obviously the derivative of 4, that's a constant, that's just 0. So this is my implicit, what we call differentiation. That's this step here, or over here if we want to use the y prime notation. Either one is fine by me. And then finally, what do we do at the end? We solve for dy over dx, or what we did over here, we solve for y prime. Because dy over dx is the derivative. So that's the idea. It depends, this derivative will depend on both x and y values. If you notice in this derivative, it doesn't say y prime equals blah 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 with just x. It has both x and y involved in this derivative. So for this example, I want to take the derivative, or the ddx of this whole thing. And the first one is pretty easy. The derivative of y to the third is 3y squared times, we're going to use the y prime notation. But then this next one is going to be a little bit more difficult. You have to pay attention. These are 2 functions multiplying each other. So it's going to have to be a product rule 1. So I'm going to do this off to the side. Notice I include the negative in front of the x. So my 2 functions are negative x. Its derivative is negative 1. The second function that's multiplying each other is y, and that derivative is 1 times y prime. Okay, so when I do my crisscross, I do this way first, and I'm going to get minus 1y, And when I do this way, I'm going to get minus 1xy prime. Okay, so these two things together in green is the product rule of the function negative xy, and then obviously the derivative of negative 6 is 0. So I want to solve for y prime. So what I'm going to do is I'm going to add. So when I solve for y prime, I'm going to add this over to the other side. I have 3y squared y prime minus xy prime is equal to y, because I'm going to get all the y primes on one side and everything else without a y prime on the other side. So I usually would move everything to the left that has a y prime and everything without to the right. And then I could factor out a y prime. And I have y prime, and I have parentheses is equal to y, and I notice I have a 3y squared minus x inside the parentheses, kind of like the reverse distributive property. And then I could divide out by this. And what I do to the one side, I do to the other side. And when I'm done, I get my dy over dx, which is the same thing as y prime is equal to y divided by 3y squared minus x. It's going to be a lot of algebra involved in this and a lot of rearranging, but it's not above your abilities, and you just got to keep things, isolated and move things around, but it's not too bad. Okay, let's try some examples. My instructions are that a, b, and c are constants. That means they're just numbers. So when I take the d dx of this, well, this first term is going to be 2ax plus 2by, and there's a y there, so it's going to be a dy dx with it, or y prime, whatever you want to call it, equals, and the derivative of c squared, which is just a number, is 0. So now I have to isolate. I got to solve for this y prime, so I'm going to subtract this 2ax over. I get 2by times dy over dx, or my derivative, is equal to negative 2ax. And I can divide out by 2by, and the b's cancel, the 2's cancel. I get negative ax over by. And that is the derivative, doing implicit differentiation of that problem. So this next problem, maybe it's best if I'm going to take the d dx of this. Maybe it's best if I rewrite this as x to the 1/2. So the derivative of this is going to be 1/2 x to the negative 1/2 is equal to 5 times 1 over y, or 5 over y, times, again, every time I take a derivative of a y variable, I have to put in an extra times. In this case, I'm going to do y prime. So I can rewrite this a little bit, and I get 1 over 2 square root of x is equal to 5 over y times y prime. And if I want to get this y prime by itself, I want to isolate y prime by itself, I can multiply this by the reciprocal, which is y over 5. And when I do the one side, I do the other side. And when I'm done, I get y prime, or my dy over dx, same thing, is equal to y over 10 square root of x. Next couple of examples. Again, I have y's all over the place. I'm going to take the d dx of this. Derivative sign is cosine y times, oh yeah, there has to be an extra y prime with it, is equal to, let's see, derivative of 2x is just 2, and there's no extra thing. I could divide by cosine y, divide by cosine y. So I get y prime is equal to 2 cosine y which is really just 2 secant of y. But you can leave it as 2 over cosine of y. I don't care. They're the same thing to me. Now this next one is going to take a little bit more work. I'm going to move it over here so I have more space. Because when I look at this, and I want to take the d dx of this whole thing, I notice right away I have a product rule. That's an x function times a y function. So I can do my product rule on the side here. Derivative of x is 1. Derivative of y is 1y prime, or d dx. I'm going to use y prime notation, and I do my crisscross. I do this way first. And I get this is equal to 1y plus the other crisscross is 1xy prime. That is the product rule of this, plus derivative of x is 1, plus the derivative of y is 1y prime, and then the derivative of 5 is 0. So this part was the product rule. Okay, I'm going to isolate. I'm going to solve for y prime. To me, does this have a y prime? No. I'm going to move him over to the other side. This has a y prime. He stays. Does this have a y prime? No. He moves. Does this have a y prime? He stays. And when I do to one side, I do the other. So I have x y prime plus y prime is equal to negative y minus 1. And now I have to factor out a y prime because I want to isolate it. What would I have left inside of parentheses? X plus 1 is equal to negative y minus 1. And then I can divide out by this x plus 1. X plus 1. I get my y prime equals dy over dx is equal to negative y minus 1 over x plus 1. And there we go. A nice derivative. Okay, the front page were somewhat easier ones. This back page is going to be a little bit harder because when I take the d dx of this whole thing, again, right away, I see a product rule right here. So I'm going to do an x squared, 2x, I'm going to do a y cubed, 3y squared. Oh yeah, anytime there's a y, I got to put in an extra. I'm going to do dy over dx this time. I don't use it too often, but I'm going to use it once in a while. So when I do this product rule, I do this crisscross first. I put numbers in front. I do my letters in order x and y, so I get 2x y cubed plus 3x squared y squared dy over dx. This part is just the product rule. Then when I do the rest of the problem, I can move this over here. Well, I'm not even going to worry about that. So when I do the rest of the problem, I'll just do it in purple. Plus the derivative of that is going to be 3x squared. Derivative of that is going to be plus 2y. Oh, there's a y. Got to put in an extra dy dx. And then the derivative of 5 is equal to 0. Okay, now it's time to reorganize. Y prime, no. He has to move. Y prime in this term stays. Y prime, no, it's got to move. Y prime, yes, stays. And when I do to one side, I do to the other. So right now I have 3x squared y squared dy over dx plus 2y dy over dx is equal to negative 2x y cubed minus 3x squared. I can factor out my y prime, or my dy over dx. I get 3x squared y squared plus 2y is equal to negative 2xy cubed minus 3x squared. And then I can divide by all this. And I'm going to get my dy over dx is equal to negative 2xy cubed minus 3x squared over 3x squared y squared plus 2y. Yep, Got a lot of variables there. There's a lot of organization that needs to go on in these problems. You've got to keep your variables straight. So I started this one a little bit, and I saw right away x squared y is a product rule. I set up my product rule. I do this crisscross first. I get 2xy plus the other way is going to be 1x squared, and this time I'm going to use y prime minus, well, 2e to the something is still 2e to the same something. Oh, there's a y there. Times another y prime, and then derivative of 5 is 0 equals 0. I'm going to decide what needs to move, what needs to stay. This needs to move to the same other side because it doesn't have a y prime. This stays, this stays. I get x squared times y prime minus 2e to the y times y prime is equal to negative 2xy. When I move it over to the other side, I can factor out my y prime, x squared minus 2e to the y is equal to negative 2xy, and I can divide by all this. Y prime, or my dy over dx, equals negative 2xy over x squared minus 2e to the y. There's that derivative. Well, this one's not so bad. No product rule. A lot of y's. Take this derivative. X squared becomes 2x plus 4y cubed becomes 12y squared. Oh yeah, y prime equals 6x squared plus 5y prime. Now I'm going to reorganize. I like to put all my y primes on the left. It doesn't matter. As long as you're consistent, it doesn't really matter. So in my view, does this have a y prime? No, he's going to move to the right. This has a y prime, he stays on the left. Does this have a y prime? No, so he stays on the right, and this has to move to the left. And when I reorganize everything, I get 12y squared y prime minus 5y prime is equal to 6x squared minus 2x. That's me just reorganizing everything. And then I decide I can factor out a y prime, 12y squared minus 5 is equal to 6x squared minus 2x. And then I could divide by all this. So I get my dy over dx, or my y prime, is equal to 6x squared minus 2x over 12y squared minus 5. That's that derivative. Okay? It's just reorganizing things. This last problem, oh, there's going to be some work. Ooh, this one's going to be some work because what I see here, I have two product rules. Look at that. One on each side. So I'm going to have to do a 3x squared, 6x, and a y squared becomes 2y, y prime. And I have another product rule which is going to be 2x, which is 2, y becomes 1y prime. So I'll start off in the green. I'm going to take the derivative of all this stuff. I hate when I grab the top of it by mistake. Keep on grabbing the top. Too close to the top. Well, you can see I'm going to take the ddx of this whole thing. (6x y squared) plus, and I do it this way, I multiply the numbers first. So close to the top, multiply the numbers first. 3 times 2 is 6. I get an x squared. I get a y. I have a y prime. And I have a minus 1 for this x. And then this is a minus 3 times 3, so it's minus 9y squared. Oh yeah, there was a y with that. So I need a y prime equals, and I can do my product rule here. I do this side first. 2y plus 2xy prime. Wow, that was a lot. I'm going to reorganize. Does this have a y prime with it? No, it does not. He's going to move. This stays. This has to move. This stays. This does not have a y prime, so he stays on the right, and this has to move to the left. So I get 6x squared y times y prime minus 9y squared y prime minus 2x y prime is equal to 2y minus 6xy squared plus 1 when I reorganize everything, and then I could take out a y prime, and I get a 6x squared y minus 9y squared minus 2x is equal to 2y minus 6xy squared plus 1. And then I can divide by this whole thing, and I get my dy. Well, I'm going to use a different color. I get my dy over dx, or y prime, is equal to 2y minus 6xy squared plus 1 over 6x squared y minus 9y squared minus 2x. And that's a big, long derivative with fractions. Okay, ask questions.